All right, so today you were introduced to function machines and function notation. Um, when it comes to function notation, it talks about inputs and outputs. That's a little bit different than the X and Y that we've been using. We're going to be working on function notation throughout the year. Function notation is it's very specific, and it really does a nice job of showing the relationship between an input and an output. So the input is always your X. The output in the past has always been the Y. But in this case, we're going to call it f of x because the output is really a function. It's a relationship to that input. So when you plug in 3, so here's the function machine. And normally we would be trying to find our y when x is 3. So we're still going to do all that same work, but because we're going to plug x in, we're going to plug 3 in for x. The work looks like this. We have f of 3 is equal to 3 squared minus 1. So we say f of 3, which just really means the function of 3. This is the function, the machine that we're putting it through. So the function of 3 is equal to 3 squared minus 1. Another way to say this right here is this is finding my y. If I were making a table and I have x and y, and I would plug in 3, well, 3 squared, so f of 3 is equal to 3 squared, which is 9, minus 1. So f of 3 is equal to 8. So if I were to use this equation, notice when I plug in 3 squared minus 1 is equal to 8. It's the same idea here. This function notation right here just shows that this is the output when the input is 3. If I just use my equation here, it does lack some information. It says find y when x is 3, so you have to go through all that information. So I would have to tell you what the input is if we were trying to find the value here. Whereas if I see this, I automatically know right here, I know in my answer the coordinate point, I know the input, I know the output. So the notation is just different. It's all the same stuff you've been doing before. So when I go to the next, when you went to the next slide, so this was the first one where they talked through it. When you go to the next slide, and it asks you, we're still using f of x is equal to x squared minus 1. It asks you to find that f of 4. So I'm just going to plug in 4 wherever I see x. Just like we practiced last week with substitution. This side doesn't really change. It says find the function value if x is 4. So find f of 4, and that's 16 minus 1. So f of 4 is going to equal 15. The next problem says, wait, now find f of negative 1. So it's the same idea. I'm going to plug in negative 1 wherever I see x. And so the f of negative 1 is equal to, negative 1 squared, which is 1, and 1 minus 1. So the f of negative 1 is equal to 0. And it says, oh, wait, now find f of 10. So wherever I see x, I'm going to plug in 10. So f of 10 is going to equal, 100 minus 1. F of 10 is equal to 99. Okay. So this is, you can check your answers. You're going to practice this a whole bunch more tomorrow. Now the last one though says, if the output of this function is 24, what was the input? So now it's saying, if you know this output part right here, what would make that 24? So, or what x value would make that 24? So I'm going to put 24 on this side, and I have to figure out what number squared minus 1 equals 24. Now, you probably would do that with guess and check, but I am going to show you how to do it algebraically. I'd add 1. I get 25 is equal to x squared. The square root of 25 is 5 or negative 5. Okay? All right, hopefully that helps. We're going to practice this some more tomorrow.